Hi, I'm John Blyler, Chief Content Officer at Extension Media. And today I have the pleasure of talking to CJ Clark, who's the CEO of Intellitech Corp. And we're going to talk about test reuse from IP to systems. So let's get started. CJ, what is meant by silicon instruments?
Hi, John. Silicon instruments are all the things that you put in your chip for verification, for monitoring. That's not part of the mission mode. Some people refer to this as infrastructure IP. And it can be things like an electronic chip ID, SerDes, PRBS, voltage and temperature monitor.
Okay, excellent. I've seen in several places that you've been quoted as talking about the new updated IEEE 1149.1 2013 JTAG standard, and you refer to it as not your father's JTAG. What do you mean?
Sure. Well, 1149.1 started out originally in 1990. And some people know what 1149.1 is about, but they might know only the boundary scan aspect. 1149.1 2013, the new update, changes that by going into much more depth inside of the chip. And it's designed to really lower industry costs by looking at the IC's life cycle. So looking at all phases of the product life cycle, from IC design, validation, through IC test, board test, and field test, and enabling that reuse through the tab. And what we've done is made the IP interface plug and play using IEEE 1500 interfaces. You can now connect together your IP inside of the chip using 1149.1. So you can have a temperature monitor, PRBS, droop monitor, and plug those together and have operation through the tab. And what it's all based on is really enabling knowledge transfer. So we have the IP designer who knows the most about his IP. He has the most IP domain expertise. And he can now describe at 1149.1 how to operate his IP and pass that information on to his customers, which are the IP designers, and then they can pass it on to the rest of the community, like board designers and test engineers. And what we've done is standardize the IP documentation. So you can now describe what is the IP you have for an interface, and then also standardize how do you operate. And when you describe how to operate the IP, that code never changes. So in this case with the PRBS, you can write this just one time and then not need to change that documentation again.
Wow, that's some significant changes there. I think in the .1 update uses a hierarchical approach, if I remember right. Would you talk a little bit about what that means and why that approach is a benefit both to the IP designer and then also the IC designer?
Yeah, sure, John. It really is based on write once, read many. So you've heard of worm before, worm drive. It's the same idea here. Write once. The IP writer writes the operation of the IP one time. And then when the IP is instantiated in the IP design, then that information can be converted automatically by tools such that the IP designer doesn't have to rewrite any of the code, and the IC designer doesn't have to rewrite any of the code. So that's what we mean by hierarchy. It's the same as the design hierarchy. You instantiate the IP at the low level, and you can instantiate it multiple times all the way up to the chip level. And then once you instantiate it, then the tools take over in terms of showing you how to operate that IP through the one description that the IP designer did.
Okay, very good. So it's important that the IP be verified. How can the IP provider make sure that the IP is indeed validated and verified?
Sure. One way of doing that is with Intellitech Software. So we have a plugin that plugs into verification engines. Our tool reads in the descriptions of the silicon instruments and IP. It reads in the operation of the IP through PDL, and then we drive the verification environment. We recently announced operation with Mentor Questa, which is a verification engine, And we're working with other EDA tool vendors to provide an interface into that verification.
There is a standardized language for operating a TAP accessible IP. Why not use test vectors like style or core test language?
Yeah, sure. Really, the test vectors aren't really proficient for silicon industry. One, they're not reusable, so they don't have the ability to give you hierarchy and reuse. The other problem is that they're not really ready to translate into a human understandable value. A good example is this temperature monitor. The temperature monitor changes the voltage based on the temperature, and it uses an equation that's nonlinear. So rather than dealing with a bunch of ones and zeros like you have with test vectors, IEEE 1149.1 PDL gives you the ability to instantiate a formula in the PDL, such that you can print out to the user a temperature value in centigrade or in Fahrenheit.
Wow, cool. All right. This sounds great. How can the design community get started with the updated 1149.1?
Well, really two ways, right? One way is to start specifying to your vendors, the IP providers or IC vendors, 1149.1 2013 compliant operation. So if your IP is compliant and the documentation is compliant, then that's one way to move forward. Another way is working with Intellitech. One of the products we offer is Nebula software, and it allows us to access these silicon instruments via the tab. It has a PDL developer, a Procedural Description Language developer, that lets you create the PDL and then validate that PDL such that you know what you're delivering to your customer is compliant. And just one way to get started would be to register on Intellitech's website, and then you can download the free Nebula software.
Free is a great way to start. Great. Thank you.
You're welcome. Yeah, thanks for the question, John. I appreciate it.